simplifying radicals by adding, subtracting, multiplying, dividing. So basically all 4 operations. And this will build up on the lesson that we did prior to this. So in order to do this lesson, you need to know how to do the lesson 3 stuff. So you need to know how to extract radicals or roots from radicals. But then you also have to, on top of that, you have to use the operations and simplify them. So we're going to tackle multiplication and division first. So I basically broke it down into 2 categories. So on one side you have where the roots are the same or the index is the same. So like if you had, you know, cube root of x times the cube root of, you know, x squared, where those indexes are the same. And then you have when they're different. Okay, so when they're the same, what you want to do is you want to multiply any numbers in front of the radicals. So like if you had a, you know, the 2 in front of the radical and the 3, you multiply it and get 6. Get rid of that stuff first. The second step is to multiply or divide under the common radical. All right, so in this example, we had 2x and 3x squared on the insides or under the radicals. So then that gives you 2 times 3 is 6, and then x times x squared is x to the 3rd. So that's what we did. We multiplied under the radical. And then you want to convert from the radical form to the exponential form. So for example, in this example where we had 6x to the 3rd, you want to convert it to the exponential form. In order to do that, you're going to remember that square root means 1/2 power. All right, remember that is power over index, right? So the power here is a 1 for the whole thing, and then the index here is an invisible 2, so it becomes to the 1/2 power. And then in this case, you know, you have, you know, 6 to the 1/2 power, which is square root of 6. 6 to the 1/2 power, and then you have x to the 3/2 power. So square root of 6 is just, you know, it's just going to be square root of 6, so we can leave it like that. And then x to the 3/2 is the same thing as x to the 2/2 and x to the 1/2. All right, and then now that we have that, then we can put everything back into to the square root form. So in that case, it would just be, you know, putting everything back. Let me write this as 2/2 here. All right, and then for the last step, convert it back to radical form. So in this example, you know, you would convert it back to the square root of 6, and then you still have the x to the 1/2, so that's the square root of x, and then you have x to the 2/2. So remember that x to the 2/2 is the same thing as square root of x squared, and remember that every time you have every time you get a whole number from whenever you do the square root of an even root, you're going to get an absolute value. So this will give you absolute value. All right, so then we're going to have absolute value of x. So then we're going to put them together. You can multiply the 6 and the x together in the radical, and you get square root of 6x. Okay, so that's just an example of how to do that. We're going to do more examples. So let's look at number 1, part A. So you want to perform the operation, whether it's multiplication or division. So here we're multiplying. So we're going to, first step is multiply any numbers on in front of the radicals, which there are no numbers in front, so we're done there. We don't have to do that step. The next step is multiply under the common radical. So we're going to do this. So we got a to the 5th times a to the 3rd is a to the 8th. Remember that when we multiply, we really are adding the exponents, okay? And then b to the 2nd times b to the 7th is b to the 9th. All right, so now we're going to, you know, practice writing this in exponential form. So this, remember, this is the fourth root, right? So if this is the fourth root, that means that I have a 1/4 power here, because there's a one, the whole thing has a 1 power, invisible 1 power there, and then the index is 4, so it's 1/4. Then you distribute the 1/4, right? So you have a to the 8/4. 8 times 1/4 is 8/4. B to the 9 times 1/4 is 9/4. All right, so now you have a to the 8/4. So 8 divided by 4 is 2. So I got a whole number from this. But since I did an even root, I'm going to just do, since I'm doing a fourth root, I'm going to write it as absolute value of a squared. Okay. And I do that, and I remember that rule. I use that rule every time I'm in an even power and I get like a whole number, like, you know, everything to cancel out for that part. Even if it's positive or even if it's even or odd, just because I want you guys to get in the habit of writing absolute value. In this case, if you're squaring something, it doesn't matter if you write absolute value, but I want you to get into the habit that if you have an even root and it cancels out, you get absolute value. So this is why I'm writing it always, even though you don't have to in this case. Now in this case, we have b to the 9/4 is the same thing as 8/4 and 1/4. And the reason I do that is because 8 divided by 4 is 2. So now again, same thing, same deal. I'm going to write it as absolute value. And then now I have b to the 1/4, which I can write down as a fourth root of b. This should be a fourth root, and let me erase that so it looks nicer. All right, and then I'm going to combine these under one thing. And there it is. There's my answer, my final answer. Again, you can drop the absolute value, but I want you guys to practice writing it. This is why I'm including it here. Okay. All right. So let's do part B. So now we're going to multiply these numbers first. The numbers in front of the radical. So that's going to be 6. All right. So we got. So that'll be 6. I'm now going to multiply inside the radical. So we got 2 times 2 is 4. P to the 5th times P is P to the 6th. Q to the 9 times Q to the 3rd is Q to the 12th. All right, now we're going to rewrite this. We know that the square root of 4 is 2, so I'm going to go ahead and just pull that out. Just to make it easier, so I'm going to pull out that square root of 4. I know that's going to be 2. And then 2, so I'm going to do 6 times 2. I'm going to pull that out as a 2. And then I'll do this part. If this is like it works out nicely, just go ahead and do it out, you know? Like if this were 36, then that would be 6. Square root of 36 is 6. And then you would do 6 times 6. All right, so then this will give me 12. Now I'm going to rewrite this as exponent form. So I got P to the 6th, Q to the 12th, raised to the 1/2 power. The whole thing is 1/2 power, invisible 2 there. Now distribute, so 6 times 1/2 is 3. And then Q, and then 12 times 1/2 is 6. All right, and now, again, since I did an even root, I'm going to go ahead and do the absolute value here, okay? So I'm going to do the absolute value over everything there. Since I'm doing an even root, okay? A square root is even root, all right? So I'm going to put the absolute value there and call it a day. It's already, I don't have to put it in radical form because it's already whole numbers, so we're good here. That's our final answer. All right, so let's look at the next one. Let's see. All right. All right, so here we're dividing this time instead of multiplying. So what we're going to do is we're going to dividing numbers in front. There are no numbers in front of the radicals, so we're good here. So therefore, I'm going to just focus on dividing under a common radical. That's one of your radical properties. If you're dividing separate radicals, and you can divide the whole thing under a common radical. Now, r to the third divided by r to the 1. Remember that you subtract the exponents when you're dividing. So this will give me r to the second, because 3 minus 1 is 2. T to the 5 minus 4 is 1, so t to the 1 power. Again, I'm going to write this in exponential form. So now I have 2 halves or 2 times a half is the 1 power. And then t to the 1 times a half is just going to be half. Now, I got to do an absolute value around this because I did a square root, okay? If I did a cube root, I don't need the absolute value. But since I did a square root, I'm going to include it. Put it back in radical form. And there's my guy. All right, so now part D, again, for the first step, you're going to do the division, okay? Simplify this. So 9 over 27, that's the same thing as 1/3, okay? Because 27 divided by 9 is 3. So I'm going to rewrite that as 1/3. There's an invisible 1 here. I'll write it out here, but you don't have to write it because it's invisible. And then third, so I simplified that. All right, so that's 1/3. Now I can divide under a common radical here. Don't forget that 3 when you do it. So what I'm going to do is I'm going to just kind of leave that 1/3 out there. Just kind of leave it alone. And then focus on the division part. Oh, also, I'm going to do one thing before I do the division. So we know that the square root of 16 is 4. All right, so what I'm going to do is I'm going to pull this out as a 4, and I know that 3 times 4 is 12. Okay, so I'm gonna write this out. I'm gonna pull that out as a 4, and then I'll focus on the division. I forgot to do that part, just so that we can get rid of the numbers and get them over with. All right, so now this is going to be 3 times 4, which is 12. So I got 1 over 12. Now we're going to subtract. So we got a to the third minus a to the 8th. Okay, so that's going to give me 3 minus 8 is -5. So I got square root of a to the -5. Now I got b to the 4th minus 7. So now I'm going to do, that's going to give me -3. Again, when you have a negative exponent, that means you flip it. So if it's in the numerator, then you flip it to the denominator. If it's in the denominator, flip it to the numerator. So I'm going to do that real quick. So I'm going to flip both of these to the denominator. All right, so now I'm going to go ahead and convert back to exponential form. At this point, I can put the 12 next to the radical, or next to this guy. So I'm going to rewrite that first. So I got this now. Okay, so I'm going to rewrite that radical as a half power. So I got a to the 5 halves, b to the 3 halves. All right, so now a to the 5 halves is a to the 4 halves and a to the 1/2. And b to the 3/2 is b to the 2/2 and b to the 1/2. All right, so now I know that a to the 4/2 is a squared. Since I did a square root, I'm going to write it as absolute value. And then the same thing for the b here. I'm going to write that as absolute value. And then I have a to the 1/2 and b to the 1/2. All right, so I'm going to rewrite this as a radical. A to the 1/2 is square root. And then I'm going to combine these under one absolute value. And then I'll call it a day for this. Since these are both 1/2 power, I'm going to go ahead and combine them under one radical. And there you go. So that's how you write it. It's a little bit complicated because of the negative exponent, but I wanted to give you guys an example with that so you can practice with negative exponents. All right, so now we're going to look at what happens if the roots are different. Okay, so for example, if you had the 4th root of x times the 4th root, or the 5th root of x squared, like how would you do that? See, the indexes are different because 4 and 5. So what you do is you multiply or divide any numbers in front of the radicals, just like we did before. The 2 times the 3 gave us the 6. And then convert from radical to exponential form. Let me see if I actually filled in the notes here. Yeah, I forgot to write it down here. This is to exponential form. All right, had a feeling I forgot something there. Now simplify using your exponent properties from before, just like we did in the other step, and then convert back to radical form. All right, so we're going to do part A. So now please note that this here should be a 4th power, not a 3rd power. Okay, so that was a typo. All right, so now we're going to go ahead and proceed with the problem. So first step is to multiply any coefficients in front of the radicals or any numbers in front of the radicals. In this case, there are no numbers in front of the radicals, so we can skip that step. Next step is to convert to the exponential notation. So this is going to be x squared y to the 4th raised to the, now you can think of the whole thing as being raised to the 1 power, so we got 1/5. And then here it's just going to be power over index, so it's 4 over 3. All right, and in this case you would have 2 times a 5th is 2/5. Remember, you're going to distribute that. And then 4 times 1/5 is 4/5. And then now we have x to the 4/3. This is a y, sorry. This is not an x. That's a y. All right. Now we're going to combine the x's together. You see the 2/5 and the 4/3? Since we're multiplying those x's together, that means we add the exponents together. So we're going to add those two exponents. So it's going to be x to the 2/5 plus 4/3. And then of course we have the y to the 4/5 on the side. So we got to combine 2/5 and 4/3. All right, so I'm going to do that on the side here. 2/5 plus 4/3. Common denominator is 15, so I need to times this by 3. I need to times this by 3, and that gives me 6 over 15. I need to times this by 5 to make it 15. Whatever I do on bottom, I do on top. So that becomes 20 over 15. This is on the side. Now we can combine the fractions. 6 plus 20 is 26, so I got 26 over 15. Also keep in mind that 26 over 15 is the same thing as 1, or as 15 over 15, and 11 over 15. Okay, so I'm going to also keep that in mind because I'm going to rewrite that later. So x is going to be 26 over 15, and then we have y to the 4/5. Now I'm going to rewrite the 26 over 15 as 15 over 15 and 11 over 15. And then of course we got the y. All right, the reason I do that, 15 over 15 is 1. All right, so this becomes 1. And so I got x to the 1 power. Since I did an odd root, 15 is odd. That means I don't need the absolute value. All right. And now we're going to go ahead and rewrite this in radical. So x to the 11/5. So it's power over index. So the index is 15. And then the x. So the index is 15 and then the power is 11. And then here for the y, the index is 5 and the power is 4. All right, and there's our final answer. So now we're going to look at part B. So in this example, let me separate those two. So here we have a -1, and we have a +1 in front of here. So -1 times 1 is going to be negative. All right, so I'm just going to put a negative there. Now we're going to go ahead and rewrite this in terms of exponents. So we have 27 s to the 5th t to the 8th. Now the whole thing has a power of 1, and then we have a invisible index of 2 here, so it's going to be 1/2 power. And then again, same thing here, s to the 6th t to the 9th. You can think of the whole thing as having a power of 1, and then 1/3 because of the index is 3 there. All right, so now we have distribute the 1/2, so we got negative 27 to the 1/2, and we have s to the 5/2, and then t to the 8/2. And now we have for the other side s to the 6/3, and then t to the 9 times 1/3 is 9/3. Okay. So now what we're going to do, we're going to go ahead and I'm going to simplify the 27 to the 1/2 power, okay? So I'm going to do that on the sides so that you guys can see that, okay? So I'm going to do that. I'm going to do that here. So let me do that here. So 27 to the 1/2 power. So we know that's the square root of 27, right? So the square root of 27, what you can do to simplify that, you can break it down into 9 times 3, because the square root of 9 is 3. All right, so that will take care of that part. So the square root of 9 is 3, and then you can't do the square root of 3. So I'm going to rewrite the 27 to the 1/2 power as 3 times the square root of 3. All right, so I'll do that later in a little bit. So I'm going to leave it as this, and then in the final step, I'll rewrite it as 3 square root of 3. Now we're going to combine the powers for s. So we got to add them together. So we got 5/2 plus 6/3. 6/3 is the same thing as 2. So I have 2 over 1 here. And then for the t, I have to the 4th power, so 4 plus 9/3. Oh, 9/3 is just 3. So I'm going to write it as 3. Okay, so then let me go ahead and we're already done with the t's here. So I just want to be careful with here. This whole thing is going to be negative. Okay. So now 5/2 plus, so 5 over 2 plus 2 over 1. So 2 over 1 is the same thing as 4 over 2. Right? So I'm going to rewrite that as s to the 5 over 2 plus 4 over 2. And then that's just going to be 7. 5 plus 4 is 9, so it becomes 9 over 2. All right, so I have s to the 9 over 2. Okay, so 9 over 2 is 8 over 2 and 1 over 2. Again, once you get really good at this, you don't have to break it down into this many steps, but I'm breaking it down so that you guys can see the process. So this is 8 over 2 and 1 over 2. 8 over 2 is going to be fourth power, and we're going to do absolute value since we're doing the square root. Okay. Now I'm going to rewrite everything in terms of square roots and all that stuff. So now I'm going to rewrite the 27 as -3, as a 3 times square root of 3. I'm not going to forget the absolute value of s to the 4th. Square root of s is just, or s to the 1/2 is square root of s, and then we have t to the 7th. All right, so I'm just going to put it together, and I'm going to put these square roots under one common square root. So we have, I'm going to put everything together. So -3 square root of 3. Let me give myself some more room here. So -3 square root of 3. Absolute value, s to the 4th. I got t to the 7th, and then square root. Oops, sorry guys. This is going to be I'm going to combine the square roots together. So -3 absolute value, s to the 4th, times t to the 7th, and I'm going to combine these square roots under one square root. Square root of 3s. All right, and that's it. All right. Okay, so now we're gonna go ahead. I'm gonna go ahead and do the do part C. So here we're gonna divide those numbers, but 7 over 5th is not a nice number, so I'm gonna leave it as 7 over 5. I'm gonna rewrite the x, this 4th root of x as x to the 1/4 power, all that stuff. I'm gonna put these under one. So all right, so I got the -7. I'm gonna rewrite the x as x to the 1/4. Write the cube root of x as x to the 1/3, and then I'm going to use my exponent properties. So I'm simply going to subtract the exponent since I'm dividing here. All right, so I got -7/5, and then I have x to the, now I'm going to subtract, so I got 1/4 minus 1/3. All right, so I'm going to do that on the side. The common denominator is 12, so I need to times this by 3, times this by 3. I need to times this by 4 and times it by 4 to get 12 on the denominator. So I get 3 over 12 and 4 over 12, which gives me -1 over 12. All right, so I'm going to replace this. So -7 x to the -1 over 12 over 5. Remember, the negative means that you flip it. So you flip it and then forget it. Forget the sign. So I'm going to flip the x down to the bottom now. And it becomes positive 1/2. And I can replace the 1/2 with square root. And that's it. Now I'm going to look at part D. All right, so I know that 9 divided by 3 is 3, so I'm going to do that part first. There. I'm going to replace the square root with, now we can skip straight to it. Now that we know that, now that I've been doing this a few times, I'm going to just go straight to it. So now this square root of a cubed is going to be 3/2, and then b to the 4th square root is going to be b to the 4 over 2. I'm going to go straight to it. All right, Square root of 6, or the fourth root of 16. The fourth root of 16 is 2. So I'm going to just write that as, 2. That's what this guy is. All right, because 2 times 2 times 2 times 2, 4 times is 16. And then we have a to the 8 fourths, so 8 over 4. And then b to the 6 over 4. All right. So now I'm going to go ahead and subtract. I'm going to go ahead and simplify first. So we got a to the 3 halves, b squared. Now this would normally be absolute value, right? But I'm not going to do the absolute value because I still got more stuff to do. I still got the 6/4 that I got to subtract from it and all that stuff. Eight over 4 is 2, and then we have 6 over 4 reduces to 3 over 2. All right, let's do a little bit more simplifying. So 3 halves minus 2. So let's do that on the side here. 3 halves minus 2. So we got, because we got to subtract the exponents. So 3 over 2 minus 2 over 1, common denominator of 2. So times 2 times 2. 3 over 2 minus 4 over 2 is negative 1 over 2. All right, so this gives me a to the negative 1 over 2. So we got a to the negative 1 over 2. All right, now let's do the 2 minus 3 over 2. Well, we kind of did that here, didn't we? 2 minus 3 over 2 is the same thing as 4 over 2 minus 3 over 2, which is 1 over 2. All right, so that's going to be b to the 1 over 2. And then don't forget the 2 on the bottom. Now, since this is negative, you're going to flip it down. So we got 2a to the 1/2. All right, rewrite it as a radical. So b to the 1/2 is the same thing as square root. And then we have a to the 1/2 is the same thing as square root. And if you want, you can rewrite this as square root of b over a and combine it under one radical. Either one is correct. Either one. All right, so they're both correct. All right, so now we're going to go ahead and do addition and subtraction. To add or subtract radicals, you must have the same index. You must have the same variables and powers for the variables. All right, so for example, here we have, the same variables. We have x, and then we have 3, and then we have x on the inside. So we have x on the inside and outside. We have the same index, 3, so we can combine them. So basically, they have to be like terms. If they're like terms, then we can combine them. All right, I'll give you another example. So if we had cube root, and we had 2x squared here, and then we had xy, minus, or let's do plus 3x squared cube root xy. See, we can combine these since they have the same variables, x squared and xy, and they have the same index, so we can combine it into 5x squared cube root of xy. All right, so just another example of, as long as they're like terms, you can combine them. All right, simplify all radicals by extracting roots. Combine any radicals that are like terms by adding or subtracting. So those are our 2 steps. All right, so we're going to go ahead and extract our roots and then combine. Here, there's nothing to do really. All you have to do is just, those are like terms, so you can combine them. And there's our guy. That's easy. So that's all you have to do for that one. Since they're like terms, you can add them, and there's nothing to extract. Part B is a little different story. So we're going to go ahead and first, according to the steps, we're going to simplify by extracting roots and then combine them. All right, so, oops. All right, so in this case, we're going to extract all roots. So I'm going to rewrite this. Remember, this is the same thing as 1/2 power, okay? So this is the same thing as 1/2 power. So it becomes 3 halves and 6 halves. All right, again, this is the same thing as 1/2 power and 1/2 power. So I don't need the square root anymore. So I got 7x to the 3 halves, y to the 6 halves. And I got 2x to the 2 halves, y to the 4 halves. So I got x to the 3 halves is the same thing as 2 halves, and then x to the 1/2. Y to the 6 halves is the same thing as y to the 3. Now, since I did a even root, square root, I need to put absolute value. So I'm going to put absolute value here. And then we have 7 x to the 2/2, 1/2. Y to the 6/2 is y to the 3rd, again, absolute value. And then we have 2 x to the, now x to the 2/2, that's the same thing as 1. Now since since that's an even root, I'm going to do absolute value. And then y to the 2, again, even root, so I'm going to do absolute value. This becomes 1, and I'm going to remember to do absolute value there, okay? And same thing here. So I'm going to combine these two absolute values together. So I'll do that in the next step though. All right, and then we got plus, since I'm running out of room here, plus 2 absolute value x, absolute value y squared. Okay, combine any like terms. Let's combine this under one absolute value. So and then we write the, and then hold on, so yeah, so we're gonna finish up the extraction, and then we're gonna combine the like terms. Okay, and then of course I forgot to convert back to radical form. I will do that. So I'm going to convert this to radical form, and then I'm going to combine the absolute values. So I got x, y to the 3rd, x to the 1/2 is square root. All right, so now we have, I'm going to combine these two as well, and then I got the 7 there. So 7 absolute value x, y to the 3rd, and then x to the 1/2 is square root. Okay, now here there's nothing we can do except combine them under one absolute value. All right, so if you notice, these are like terms. So let me do that. So these two are like terms because they have the same variables in the same index. So we have and there's an invisible 1 here. So 1 plus 7 gives me 8 of those. So I have a total of 8 of these guys. Okay, so that takes care of those two. This is not a like term, so I'm going to go ahead and just rewrite that. Okay, and that's how you simplify that. Okay, so do the exponent properties, extract roots, and then combine the expression. Combine them together. All right, so now for this guy. Okay, so for this guy, notice that, we already have like terms. You see these guys? They're already like terms, so we can combine them if we want to make it easier. Three of these guys and 5 of these guys. That gives us 8 of them. All right, and then of course we got to simplify it. We got to extract the roots and all that stuff. So let's do that real quick. Remember, this can be replaced as 1/3 power. So I'm going to replace that to the 1/3 power because this is a 3. So denominator is 3. So it's 5/3 and then 1/3. So 8 to the 5/3 and then 1/3. Okay, so now 5/3. We can rewrite that as 3/3 and 2/3. And then p to the 3 over 3 is 1, so we get p to the 1 power. Now, since we did an odd root, we don't need to do the absolute value. We can leave it as p. All right, you only do absolute value if you have an even root, like 2 or 4. Square root, fourth root, sixth root. All right, and then this one is p to the 2/3. So I'm going to put this in radical form now. P to the 2/3. And then q is q to the 1/3. Okay, so q to the 1 power. But you don't have to write the 1 there. I'm just writing it to show you. There you go. That's it. So obviously, you know, some problems are easier than others. So now for part D, we're gonna first simplify a little bit, extract the roots, and then combine any like terms. So I'm gonna rewrite this. This can be written as c to the 6/3 power, d to the 9/3 power. When we simplify this, we don't need absolute value because we have a 3, which is odd. Now we have c to the 10/3, d to the 15/3, and then we simplify. So we got c to the 2 power, and d to the 3rd, c to the 10/3 power. That's the same thing as 9/3 and 1/3. Okay, I do that because 9 plus 1 is 10, and I know that 9 divided by 3 is 3. That's why I do that. And then d to the 15 over 3 is 5. All right, now c to the 9 over 3 is 3. Again, no absolute value needed. And then we have the c to the 1/3 is cube root, and then we have d to the 5th. So I'm going to write the d to the 5th first, and then I'm going to write the cube root of c. I don't want to confuse the 5th power with the square root, or with the cube root. All right. Now, these are not like terms, so we can't combine them. And we can't combine them because of that cube root and because the powers are different. So we're good here. We're done. All right, so now we're looking at the next one. The last problem. All right, so in this case, I can tell that these are like terms. If you can tell, because they have the same, they have the cube root, and they have r to the 4th, s to the 3rd. Can you see that they're the same? So if I want, I can combine them before extracting roots, okay? So I'm going to do that just to save us some work so we don't have to redo a lot of stuff. So I got 9 of these guys and 3 of these guys. I don't know if you guys can tell. They're like terms because they're the exact same thing. So 9 of them minus 3 of them, it gives me 6 of them. All right, so now I can treat that as a regular problem and then do the extraction process. So extract the roots and all that. So I got 6. Now I got r to the 4/3 power over index. 3 to the 3/3 power over index. R to the 4. This is an invisible index of 2, so it's 4 over 2. And then we have s to the 3 over 2. All right. So now I'm not going to do the absolute value for the 4 over 2 because I have to add the exponents. So you don't want to do it until you do it until the very end. At the very end, if you have, you know, the even index and all that stuff, then you could do the absolute value. But for now, I'm not going to do that because I still got to combine. Oh, I'm sorry. I'm sorry. We're not multiplying. So in this case, I will put the absolute value just because you have an even index here, and I'm not combining anything else. So yeah, we are going to write the absolute value. So yeah, 4/3 power, s to the 3/3 is 1. Since it's odd, no absolute value needed. However, for this one, since it's 4 divided by 2 and 2 is even, since the square root is even, then we're going to write it as absolute value. It's good practice to do that if it's even power. even if you don't really need it per se. And then s to the 3 halves. S to the 3 halves is the same thing as s to the 2 halves and s to the 1 half. So s to the 2 halves is 1. Don't forget the absolute value. I'm going to put those two together under one absolute value. That's s to the 1 power there. And then we got this s to the 1 half here. Now we write it as radical and we're good. So we got, I like to put the s here, and then oops, I forgot to do one more thing. So we got 4/3 is the same thing as 3/3 and 1/3. And then that becomes 1. All right, so we got 6rs. So I'm going to put the rs together, and then r to the 1/3 is cube root of r. All right, I like to put the terms here before the radical. And then I got 2 absolute value r squared s, and then s to the 1 half is square root of s. All right, and then we can leave it like that. All right, I hope this helped, guys. There's a lot of different intricacies to these kind of problems, so you just got to be careful. You got to know your exponent properties, you got to know your fractions. There's no getting away from that, because there's nothing but fractions with the exponents here. So keep practicing, and you should be fine. Thank you, guys.